This was the binomial expansion question from the Deferred paper of 2023, and it was definitely a difficult question. It says the terms of the binomial expansion of x plus k over x to the power of 10 are written in ascending powers of x, where x and k are elements of R and k is a constant. Find in terms of k and x the third term of the expansion. Now, what makes it difficult is the fact that, okay, it's a binomial, right? Two terms inside the bracket, just like we have here on page 20. But the difficulty here is well, usually, most typically, it's like, in this case, x plus y, right? Two different letters. In this case, we had x plus k over x. Now, that might be okay. But how binomial expansion normally works is the first term starts off with the maximum power in what I've highlighted there, x to the power of n, and then becomes x to the power of n minus 1, n minus 2, and so on, all the way down until it actually disappears at the far side, because it becomes x to the power of 0. And the y powers, the second terms, actually are the ones that go upwards. Like here, there's a y to the power of 0, y to the power of 1, y to the power of 2, and at the end you end up with y to the power of n. So it's normally the first term is going up and the second term is going down. However, they ask it for the reverse order here. So with that in mind, then what we have to take into account is we actually have to go to the final term. So if I just click on this, it's what we actually have to do is we actually have to write our expansion in the opposite direction. So we have to reverse what we would normally do. So in this case here, what we end up with is x plus y to the power of n. And instead of starting off at 10 choose 0, we're starting off at 10 choose 10. We have x to the power of 0, where normally we would have start off at x to the power of 10. So we have the first term to the power of 0 and the last term, the second term, to the power of 10. Then it becomes 10 choose 9, x to the power of 1, k over x to the power of 9, 10 choose 8, x to the power of 2, k over x to the power of 8. So those are my first three terms. And the third term is 10 over 8, x to the power of 2 times k over x to the power of 8. And then to simplify that out, well, the 10 over 8 is going to be the 45. I'm going to have my x to the power of 2, and I'm going to have k to the power of 8 over x to the power of 8. And that will simplify down to my final answer, 45 k to the power of 8 over x to the power of 6. So that was worth 10 marks. But that led on then to the next part, okay? So people would have found that difficult, but then it said the coefficient of x to the power of 4 in this expansion was 7,680. Find the value of k. So in this case, right, the way we're writing this, like the way we're writing this, it'll be like if in this order, which of course we remember is the reverse order to normal. This would be my first term, this would be my second term, this would be my third term. And what we remember about the third term there a moment ago was like 45 k to the power of x over x to the power of 6. So in that case, like the coefficient here is 45, okay? Well, it's actually the coefficient. If I was to write that differently, I'd say it'd be 45 times k to the power of 8 times 1 over x to the power of 6. So you could say the coefficient on 1 over x to the power of 6 is 45 k to the power of 8. In this case, it says, well, what's the coefficient on x to the power of 4? So we're a long way from x to the power of 4, because this would be 1 over x to the power of 10. This would be x, when we work it out, this would be x to the power 1 over x to the power of 8. This was 1 over x to the power of 6, when we're just looking at the x's. So, okay, if we write this would be x to the power of minus 10, x to the power of minus 8, x to the power of minus 6. So, okay, our numbers are getting bigger, but we've actually got to go all the way to the 8th term. When we get to 10 choose 3 times x to the power of 7 times k over x to the power of 3. In that case there, we're going to have 10 choose 3 times x to the power of 7 times k to the power of 3 over x to the power of 3. That'll simplify down into x to the power of 4. So we get 120 k to the power of 3 times x to the power of 4. This guy here is the coefficient on x to the power of 4. So you get 120 k cubed equals 7,680 divided across by the 120, which is 64. Get the cube root of 64, which is 4. So you get k is equal to 4. And that was the answer. Now, if you're looking at this question and you're saying, what in God's name is that all about? What you should do is this. Go back up to there and put in 4 for k. And do out the expansion for the first 10 terms. And then look at it from that point of view. And all of a sudden it will look much more clear once k is out of the question. Because k just made it much more abstract again. Okay. So it was definitely a tricky question.